Now we are into part 2 of the webinar series of interior design concept to completion. In this part 2, as I have explained you in the last presentation itself, we will be talking about the representation of the drawings. That is nothing but the next stage of design. The design process, as explained you in the last session, now we have come across to the stage of after we have completed the design stage, we have completed the visualization stage, we have almost given the presentation to the client, and now we are evolving our designs. Now the evolving process not only has involves not only the detailing part of it and the to and fro information sharing with the client, but it does involve a lot of process like coordination with structural drawings, coordination with MEP services drawing, mechanical, electrical services drawings, firefighting drawings, and then finalization of the drawings in such a way that whatever we have explained and we have shown to the client in terms of concept design, we should be able to execute the same on site. So we're going ahead with the design process now. The next stage is detailed drawing. Now, for example, you are seeing this slide as a furniture layout plan of a multiplex lobby. Now, generally, you are habitual of showing the furniture layout plan with only the furniture, showing only furniture on it. But when you do a commercial interior project, it is very, very important for you to show all the elements, like all the doors has to be perfectly in place, or the partition lines are supposed to be in place, all the railing, wherever the glass railing is going to come, wherever the MS railing is going to come, everything has to be shown in the furniture layout plan itself. Then the light element, wherever the electrical contractor is supposed to work, like he is supposed to leave the electrical point or the light point, he is going to read your furniture plan in and correlate that furniture plan along with his own drawings. So this becomes, the furniture plan becomes your baseline of all the next drawings which you are going to create. So as you can see, the text where the multiplex lobby is written, there is a video wall there. Then there is a mirage signage there. So once I write signage, the contractor is aware that he is supposed to leave the electrical point just near the signage. Then I'm writing a cinema number 1 signage there. So wherever the wooden paneling line is seen, the contractor is aware the wall is not finished with the paint, but wall is finished with wooden paneling. So all these small elements are going to explain him our concept to the contractor, because the drawings is the only medium through which we share all the information to the contractor. We don't actually go and explain him in person, but drawing speaks on your behalf. So basically, each and every line and each and every information shown on the drawing is going to convey the contractor the relative information. And if you have not shown that on the drawing, mind well that the information is not going to get passed through you to the contractor, and then it will not get executed as per your concept. Now going ahead with the next slide, I will tell you like why a line out plan is important. Now you should know some things, how the design, after the design process is over and how the execution starts. Once you know the process, how the execution starts, you will prepare the drawings accordingly. Like for example, your drawings first are going to get referred by many consultants like electrical consultants, HVAC consultants, then firefighting consultants, and the contractor himself. So once he will see all your drawings, he is going to get a lot of information and instructions from the drawings itself. So as you are seeing the line out plan, this particular line out plan is of one of our project, which is a commercial office interior project. So there the central area was having loose workstations, and all around we had proposed the cabin. And the main entry was from this point. The main entry was the point where the main entry text you are seeing. Now, while giving the line out dimension, it is very, very important for you to know the actual dimensions of the site. Because sometimes whatever the drawings we work on, we get the drawings from the architects who has designed the building. Based on drawings, we start our working. But as per site dimensions, many things changes. So because of that, it is your first responsibility to check the site dimensions and to incorporate those site dimensions in your drawings itself. And after the concept stage, you convert your drawings into a format where it correlates with actual site dimensions. Now, giving the line out plan more in detail look, if you will see, there is a partition which is in a curve form. So we have given the line out of the curve with reference to one RCC column. Now you have to specify the reference line as a stagnant element on the site, which will not move. The element which you are going to refer as a reference line from has to be a stagnant element, like has to be a wall which is not going to get demolished, or has to be a column which is going to be in place forever till the site ends. So now, because this reference line becomes the reference of many line out henceforth which are going to happen on the site. Now this reference line will give all the dimensions at roughly around 200 mm center to center to form a curve partition. As per site condition, you will have to also check the center to center or the finished dimension between two columns, so that if at all you have shown any loose furniture in this area also, whether that loose furniture is fitting in that space or not, that is your responsibility to check that well in advance and inform the client well in advance before the execution that yes, we have planned for it, but now as per the site conditions, it is not fitting in. Some of the elements we have to revise and looked at. Then while doing the line out of all the stagnant elements like walls, like for example, if you are showing the wall thickness is 200 mm and if the contractor is going to use a brick wall of 230 mm, then the whole line out of your drawing will go waste, whole process will go waste. So when you will visit the site for the first time and when you will interact with the contractor for the first time, you're supposed to ask the contractor which material is going to use. If he's going to use a brick of 230 mm, or he's going to use 200 mm block work, or he's going to use Ciporix wall, then how much is the thickness of the block? According to that only you are supposed to show the thickness of the brick wall in your drawing also. Now, as you have observed in this layout, if we start showing the reception from the reference line, the dimension here for the meeting room is 2.4 and the dimension in the reception area is given as a stagnant dimension. But some of the dimensions, like for example, this particular large cabin dimension, we have given it as a check dimension. Why is it so? Like this particular dimension needs to be given as check. Why is it so? Because I want this wall to be aligned with the RCC column. And this is the language which we generally follow to convey what do we actually require in terms of the design. So that language is followed everywhere, and the contractor is also well aware about this language. So he comes to know when he studies the line out plan, he comes to know like where he has to keep the check dimension. Like for example, in this case, all the reception, meeting room and all 3-4 cabins are going to get a stagnant dimension of 2.4, and then the last dimension of the large cabin is going to be a check dimension. So for him, it is very clear that he has to align this particular wall with the RCC column. And later on, then after that, again the two rooms which are having stagnant dimensions, and the third room which is a cafeteria is going to have a check dimension. Now to give this as a check dimension, now again from the other corner of the RCC column, you have to give this dimension as a fixed dimension, so that he comes to know that while planning the brickwork of a toilet, because you never know like from which corner he's going to start with the brickwork. If he will start, even if he will start the brickwork of the toilet area first, he is supposed to show you the line out of the entire site first. He is supposed to show you the check dimension, whatever you have written. Suppose you have written 5,000 and CK, that is 5,000 dimension is a mandatory dimension, and still he is supposed to check the dimension and alter the dimension as per the site condition. Sometimes you might get little more space than you have shown on as per your drawing, but the most possibilities are there, like you get little lesser space, and because of that, many times your furniture layout gets compromised. So because for all this, the first site visit immediately after the line out is your responsibility to check each and every corner of the site by checking all these dimensions of the cabins. Now, for example, in this corner, you can see all the cabins are having wooden partition in between them. So he is not going to construct any brickwork in that. The wooden partition is going to get constructed through a contractor in the later stage. But he is supposed to show you the line out of the space as well, because the line out of all the cabins in this area depends on the dimension of as per site condition, and the cubicle one is going to get the compromised dimension here. As per your furniture layout also, you are aware like cubicle one might get compromised because of some discrepancies as per site conditions. So you have almost taken care of that while designing the drawing, designing the furniture layout itself. As you have shown, as you have observed, there is a door schedule showed on the right hand side. Now the door schedule, why is the door schedule important? Like when the masonry work is going to happen on site, simultaneously the contractor is going to construct the lintel for the door. So you have to give the clear opening, clear masonry opening of each door, have to give the dimension of the door, that the location of the door from RCC columns, and as well as from inside the brickwork or inside from the partition wall also. And you need to give the clear dimension of the height of the door. Now, while giving the height of the door, we generally give the height of the door from the FFL. Now, I would like to explain you like why the FFL is written as 0.0 mm here. FFL is finished floor level. And why is it written as 0.0 mm? Because as per site conditions, you might find that the main entry level, when you say the level, the slab level might be little lower, like 50 mm or sometimes 75 mm lower than the finished floor level at the main entry. Like when you enter from this area, there is going to be a finished passage, finished area from where you are going to enter in. So after the complete execution of the flooring of your site, the flooring inside the reception area and the entire site should get aligned with that same level. So you are going to write the final finished floor level as 0.0 mm, and it is contractor's responsibility to match this level with the RCC slab level. Sometimes the RCC slab level is in undulation. The PCC or the screed which he puts onto the RCC slab to level the whole site with respect to the main level is sometimes 50 mm in some corner of the site and sometimes 75 mm in the other corner of the site. So that is the contractor's responsibility to check the levels as per site conditions and to inform you if there is any discrepancy as per the site conditions. Now we will go to the next slide. As I have explained to you in the last presentation, the flooring plan, this is showing a flooring plan of the multiplex Vashi, which you have already seen in the last presentation. The flooring plan, what all information you are supposed to show on the flooring plan. Now first, as explained to you in the last slide, the floor finish of the particular area has to be written. Like if there are some levels inside your site, you are planning to have some upstand, or you're planning to have some level up than the 0.0 meter level as your finish level, then you are supposed to show that in the flooring plan itself. So all the levels should be clearly marked. Then the flooring demarcation has to be clearly marked, like how many different type of flooring are going to be there in this particular project. So all the flooring pattern has to be displayed well, and again the type of flooring has to be displayed well. This is a general nomenclature which we follow when we put forward the flooring plan. Like F1, F2 is the type of flooring. Like for example, you can see the F1 flooring is a 1 meter by 1 meter Johnson Snow White vitrified tile flooring, and F2 and F3, these are two composite marble. Now composite marble comes in the form of a slab, and it does have a problem of expansion also. So while laying the slab of a marble, you are supposed to know like what is the slab size of the marble. This agglomerated marble is artificial marble, so because of that you are already aware that the size of the marble is going to be 1.2 meter by 2.4 meter. But you cannot obviously plan for a 2.4 meter by 1.2 meter size of a marble slab to be laid in without joint. So you're supposed to show the joint of the marble in the drawing of the flooring plan itself. And also you're supposed to, whenever you are using the composite marble, you're supposed to show the expansion joint of the marble. Like in this particular drawing, you can see the blue line indicates the expansion joint of the marble, and I have shown you in detail. This you must have observed, like while walking in a mall, you can observe all such small things. Like you will see this marble expansion joint in the mall itself, because most of the malls are having the flooring as a composite marble. Now, this expansion joint you have already shown. Since there is a vitrified tile flooring in between the two marbles, the marble joint is not extended in the vitrified tile area. It is only limited to the area of marble flooring. Then the second important thing is the transition profile. Wherever you are having different flooring than the hard flooring, like for example, if you have any wooden flooring in this particular project, the Gold Class Lounge was having a wooden flooring, and all the cinema entry door has to have a transition profile shown there, because inside the cinema you have a carpet flooring. So the carpet laying happens very much at the later stage. So this is just to explain you how is the procedure of the flooring happens. Once the hard flooring is done and the entire site is done, then the carpet is laid in the last stage. So before that, only the IPS will happen inside the area wherever other than the hard flooring is going to get laid. Like for example, in Gold Class Lounge also, if you are seeing right now the wooden flooring, there also he is going to lay the IPS flooring, and the IPS flooring construction is going to happen little at the lower level. Like for example, he is going to leave the 10 mm thickness, considering the 10 mm thickness of the wooden flooring. So he is going to lay the IPS flooring 10 mm lower than the finished floor level of the lobby, so that after the completion of the entire site, both the flooring levels get matched. Now I was explaining you the line, magenta color line, which is indicating the aluminum transition profile. Now this particular area we have used two transition profiles, like that is one is aluminum transition profile where the all cinema entrances are there, and the line which is indicating in the red is the steel transition profile. The stainless steel is little costlier than the aluminum transition profile, so we use it only wherever it is going to get displayed. So at the entrance, at the multiplex entry, where you can see your flooring of the lobby is going to get merged with the flooring outside in outside passage of the mall, there you are supposed to have the line which is indicating the stainless steel profile. And the second is where the gold class lounge door is there, where two flooring, the hard flooring and the wooden flooring gets camouflaged with each other. In this slide, I'm particularly showing you the skirting detail also. Now, sometimes, as explained to you, the lobby level, the lobby slab level is down by 300 mm also. So we need to consider the filling, and as per the site condition, he will calculate the filling so that the final lobby finish level gets matched with the passage, outside passage and the entry passage level. This is a line out plan of the flooring. It is not simple to show fancy drawings in the concept and to show different things in the different drawings in the execution stage, but you have to meticulously design the flooring pattern in such a way that, and show the line out of the flooring pattern in such a way that while execution, the contractor is bound to do the mistakes. So he is supposed to refer your drawings as it is, and he's supposed to study the drawings well in detail so that he is aware, like while doing the line out of this particular curve flooring, he is supposed to form a center line of the space, which is well displayed here, the reference lines for the flooring line out, and the dimensions equal denotes that he is going to start the line out of this particular flooring with respect to the center line of the space. And after that, there is one more dimension where there is one more reference line needed. Like for example, this particular wall is another reference line that is again the start point of the flooring line out. So from that, he is supposed to take the dimensions of, actually mark the grid of 250 mm center to center, and then as per the line out dimensions, he is supposed to mark the points. Though the circles are there, and you can easily mark it with the center point and center point, you cannot show it with by marking the centers of the circle and or marking the radius of the circles. It becomes very difficult for a contractor to mark the radius and to mark the center of the circles on site. So this is a type of line out which we follow for the curve flooring. Now going ahead with the next stage. This slide is to explain you how much different transition profiles are available in market and how do we use them in terms of different types of flooring. Like for example, you can see the transition profile, which is the aluminum transition profile. In between two different hard flooring also we use it sometimes. Then the transition profile, like a wooden transition profile, you can use when two different carpets are going to get used and get two different carpet patterns are going to get fused with each other. You can use a wooden transition profile where you generally don't want a MS or a SS material to be the part of the flooring. Then you can observe the aluminum transition profile used here. The stainless steel profile looks like this. Then the PVC transition profile helps us to use the transition profile wherever the flooring transition is in curve, because the all other material are very hard material, so you cannot actually cast the curve in that. But the PVC transition profile is little flexible material which you can form a curve by using this particular material. Now the right hand side this particular aluminum transition profile is to show how the level difference between two floorings. It is important to show the level difference with the transition profile also. The transition profile gets form a small smooth curve. Because of that, the tendency of falling because of the level difference is almost negligible. Now going ahead with the coordination with structural drawings. I don't know like whether it is part of your curriculum or not, but I would like to explain you this particular drawing very much in detail. Like for example, when you study the structural drawings, you first get the plan of the structural beams, uh, where you can see all the beam nomenclature marked on the plan, and simultaneously you correlate that particular plan with the beam schedule, and you need to really study the schedule well in details to understand wherever the beam are going to come, whatever the depth of the beam is going to come, and you need to mark that in your section and your plan as well. Like for example, this is a structural section which shows the depth of the beam, but you cannot just rely on the drawing. You are supposed to relate it with the beam schedule, so that after drawing the S-shaped curve or the C-shaped paneling, as you have seen in the last presentation, it should not happen that it is not getting executed on site because of site conditions. So it is not possible for you to every time go and measure all the dimensions of the site as per site condition. But once you do a first site visit, you are supposed to check some few dimensions and later on correlate your structural drawings, then existing photographs, and sometimes taking actual dimensions and then going ahead with the actual drawing, the false ceiling drawing of your space. Now, services coordinated RCP. This is a this plays a very important role. The coordination with the structural drawings and the MEP services drawing plays a very important role when you are executing the drawings. When you are executing any project, which is a commercial project, being maybe it might be a restaurant or it might be a commercial space like office space, or it might be the multiplex. You are the captain of the ship, and because of that you are going to give the line out, and you are going to check all the services line outs as well, and you are going to instruct all the services consultant whether you're going to improvise and approve his final drawings, and then only his drawings will go to the execution. Like for example, in this particular this layout is again from the same project. This is a pre-function lobby area and pre-function lobby area of FAME Vashi Multiplex. We had proposed AHU just above the loft of the toilet area, and because of that it was easy to take out the ducts above, well above the desirable false ceiling height. So the ducts were, we have managed to take the ducts right above the false ceiling. But now to manage to give the supply at this corner, we had to allow him to give one supplier branch from this particular area. Now you are supposed to know how the execution happens on site. Like for example, the fire fighting services, the fire hydrant services, and the sprinkler risers and the hydrant risers are laid first, and then the HVAC services are executed. And after the HVAC services happen, he do the conducting for all the electrical services and all fire alarm services. So that is the method which is followed for all the services execution. Now, why we should know all these things in detail? The very basic reason, like when you show the services coordinated section, you are not supposed to show the hydrant riser level or the sprinkler riser level below the HVAC duct, so that when the HVAC duct is going to get executed, he should have a clear space around that for the execution of the HVAC duct. Now you can correlate this particular section with the as per site conditions, how the ducts have been laid, and how the sprinklers pipes have been laid, and the contractor is also supposed to give the final finish false ceiling line out to the services contractor as well. In some corner of the site, he is supposed to give the line out for the services contractor also to be aware like what is going to be the final finished height of the gypsum false ceiling. so that if at all any services is coming down than the desirable height, than the height which we have allowed him to execute, he will immediately inform us well in advance, so that after the execution of the gypsum ceiling, we should not be able to, we will not be able to do any changes in that. But sometimes, you know, because of the site conditions, if the HVAC duct is coming down, we need to propose some alterations in the false ceiling, and we do that alteration in the tender or the execution drawing stage itself. This slide is again showing you the services coordinated RCP of the main lobby of the same project, Fame Raghuleela Vashi. This you have seen the executed project in the earlier presentation. So now you are aware like how this is the S-shaped false ceiling. You enter from here. So this is the S-shaped false ceiling, and this is the C-shaped false ceiling. Now this particular coordinated RCP, we are supposed to show the services very much in detail, and the false ceiling elements little lighter, so that the services contractor gets his line out very much perfectly. As you have observed, the dimensions which we have shown for the sprinklers or for the light coves, we have written equal A and equal A dimension. We have not actually given the dimension of the particular element, but we have several times given the stagnant dimension and the check dimension. As explained to you, the line out of the in the line out slide, it is very important to do the line out of the false ceiling well, so that after execution, if I had not given the check dimensions here, and if I had not given the stagnant dimension from the RCC column, it might happen so that the layout of the false ceiling happens wrongly, and the two coves which I want it to be in symmetry with this particular column at equal distance from the column, that will not get executed as per the desired design, as per the design which we have shown to the client. So it is our responsibility while showing the execution drawings how to show the dimension, and how, because our drawings are only going to get explained to the contractor. They are only going to convey whatever style of execution we want. No other language is there. Like, we cannot keep on explaining the contractor each and every line out of the as on the site. So now, as you can see, the services coordinated RCP in this area, I will show you in the next slide. The as-built condition, you have already studied the structural beams, what was the height of the beam. So now this you have already coordinated with the HVAC services drawings. Then you have given the line out of the hydrant riser, like how the hydrant riser is supposed to take the pipe from this particular false ceiling area, and because of that, you have already planned for this much space for the supply air duct to pass through and for the hydrant riser to pass through. Now, because of that only, you are supposed to know the diameter of the pipe, of then the width of the HVAC duct, the size of the HVAC duct, and when you correlate all your false ceiling dimensions with all these services, then only it is possible to execute it as per the required height, as per the heights which you have shown in the tender stage. In the tender stage, you can easily show a C-shaped false ceiling with 2.3 meter height here and 2.3 meter height here and 2.9 meter height here. But if you will fail to do this particular coordination, your design is not going to get executed as per the desired height. It will easily come down. The two services also, if gets overlap with each other. For example, if the pipe is not laid in the way which we have shown, or which if at all you have not observed that you are supposed to show the HVAC duct line out, or you're supposed to show the pipe line out the way you want it, then the two services will get overlap with each other, and finally the fall ceiling height of the space will come down, and it will be then your fault that you have not executed it properly. Going ahead with the detailed drawings of the space, I have picked up two detailed drawings to explain you. One is a curved wooden paneling in FAME Vashi project, and another one is a main entrance door construction, main entrance door construction of the other project, FAME Bengaluru project. Now this particular drawing will explain you like why I was saying that it is important to do the line out of the partition as well. Like this particular plan shows the line out of the curved wooden paneling. How the line out of the curved wooden paneling is marked. Like for example, there is a RCC column here. You have shown the paneling, desired paneling, and after the paneling, the dimension of the column is going to be 1120 mm, and you are going to leave the dimension just beside on the left hand side corner of the column, which is different than the dimension on the right hand side of the column. Now, how the contractor is supposed to know, like how much is this dimension? If you will give 2.4 dimension, for example, if you will give 2.4 dimension on this side and 2.5 dimension on this side, then the whatever remaining dimension is going to be there as per site conditions will get compromised to the paneling of the door. So now here the stagnant dimension is 3.4 and 3.5 on both the corners. Then you give equal A and equal dimension, equal A and equal A dimension for these two portion of the paneling, and equal B for these three portion of the paneling. So because of that, the contractor is well aware that he's supposed to leave 3.4 meter dimension from this particular RCC column by showing the wooden paneling, and after the finished wooden paneling, he is supposed to leave 3415 mm. Then he's not supposed to compromise anything in the width of the wooden boxes which are going to come. Like for example, I have specifically written the 600 mm dimension as a stagnant dimension. So that particular dimension is going to get followed for while execution of this particular paneling. So whatever he is going to do, the adjustment is going to get adjusted, but by dividing it into equal parts. Though I am seeing this dimension as right now 2.1, if I have written it as a equal B, this dimension may be 2040 also as per site condition. But that is okay for me because I have already studied the site dimensions. I am aware like the as per site condition, whatever the less dimension I'm going to get or more dimension I'm going to get adjusted in these two panels. The same has been carried out in the elevation also, so that nothing gets compromised where the main elements are going to come. Like for example, this particular in this particular paneling, the cinema entrance doors are the main element. The cinema entrance door paneling is the main element. If something gets compromised, maybe if I had not given the line out in the way which I have shown, then if something gets compromised in this dimension like 3415, it gets compromised by say 300 or 400 mm. The dimension required for me to show this particular bigger signage will get compromised. So this is the way which we show the line out of the paneling. Now I will show you the detail of the paneling, the detailed construction drawing of the paneling. As I have explained you in the last presentation, the wooden construction happens till the height of 2.3. Like while you are working on a commercial project, it is very, very important for you to understand that the public is going to touch the paneling, and they might bang on the paneling, and till the height of 2.4 meter, it is the sturdiness of the paneling is very, very important. So now you can see and observe how the detail drawing is shown and how the specifications have been written. Like for example, the wooden boxing curve front fascia out of 4 numbers of 3 mm thick marine plywood 3 mm thick MDF on outermost face fixed with 38 by 38 salwood framework at 450 mm center to center, finished with approved shade of paint matching to curved ceiling. If I have not written the specification so much in detail, then the contractor will not use the framing at 450 mm center to center. He might use this at maybe 700 mm center to center, and then the strength of the paneling will get compromised. Again, secondly, if I will not write 3 mm thick, 4 numbers of 3 mm thick marine plywood, he will not give the thickness of the paneling as desired for the sturdiness of the paneling. Then the final finish of the MDF, as explained you in the last presentation, wherever we give the Duco paint finish to any surface, we generally clad it with the MDF so that we get a better finish. Now, while writing the shade of the paint also, we are supposed to write the paint to be matched with the curve ceiling, so that the paint above in the gypsum ceiling will get matched with the curve ceiling. Now you are seeing the wooden boxes which are planned in between. Like in the next slide, I will try and explain you how you can relate that particular drawing with this particular finished photograph. A wooden box which is 600 mm thick, which you have shown already in the line out, you are now showing the detail of that particular wooden box. Like the width of the wooden box is 600 mm. Then the detail of the wooden box you have shown, like for example, this face of the wooden box is Duco paint finish. Then the outer face, this particular face is finished with laminate, but there also you are writing the light box front curve fascia made out of 4 numbers of 3 mm thick marine plywood supported with 38 by 38 salwood members at 450 mm center to center from the RCC slab. Outer surface finished with Cebu or Homopal make SS glossy laminate. Now, why is it important to write all the specification? If you will miss to write any of the specification, the contractor is going to get advantage. He is going to take the advantage of that particular loophole, I would say, because he will not use the laminate which is not of Homopal make, or which is not of the make which we desire to. So all the information on the drawing has to be well written, well explained, so that the contractor gets the instructions properly and he don't take advantage of while doing the construction, and the final output is as per your desired concept drawing. These are few photographs to show you when the construction was happening. Now, for example, this particular paneling you have already seen in the finished photographs, and now in the drawing, the SS laminate and the Duco paint is camouflaged with each other. They are in one level and they are in one phase, and how the paneling is done around that. Then the rest of the space, that the curve shaped wooden paneling is formed in such a way that it forms a one uniform space, and nobody will come to know after the final execution that there is a wooden paneling up to 2.3 meter height and there is a gypsum false ceiling above that. We had to give grooves. We after finishing of the gypsum, we had to give grooves of 3 mm in this Duco paint finish, because the Duco paint finish, if the surface is very large, it is going to get cracked. Like it happened to get cracked. To avoid those cracks in the Duco paint finish in the later stages of the execution, we have given the grooves 3 mm by 3 mm grooves in this particular paneling. You can observe that in this particular photograph. Going ahead with the last detail for this for today's webinar, I'm going to explain you how the main entrance door, that is a glass door drawing, you are supposed to give to the site. Like This particular entrance door is a glass door with some fixed glasses on both the sides, and there is a curved glass element on the very much right hand side in the plan, as you can see. And there is a box office there is a box office and a wooden boxing here where two plasma LED TVs are going to get installed, and there's a cove light around this. Then the whole area, the external surface, external wall of the space is going to get cladded with ACP paneling, which is a 50 mm thick paneling with ACP sheet finished as a finished element, as a finished surface. And then we have proposed 50 mm wide wooden molding with light element inside. In the next slide, I will show you the detail of the 50 mm thick molding, how we have done that. Now, why is this particular drawing important for you to study? While doing the line out of the main entrance door, it is very, very important for you to understand like how much is the landing space needed for the main entrance door for a commercial premises when a lot of people gather outside the main entrance door just behind the multiplex entrance before entering into the space. So how much is the landing space required, that you are supposed to know. While giving the dimension of the giving the dimension in this particular drawing, you are giving the stagnant dimension as 1.8 for the door, so that any dimension as per site condition, there are changes due to site condition in any dimension, the 1.8 meter width of the door do not get compromised. You are giving equal dimension for these two particular panels of the fixed glass. You are writing the specification of the fixed glass quite in detail, 12 mm thick toughened fixed glass panels. Then again, the glass door is also having a toughened glass with the same mm thickness, 12 mm thickness. And last panel is a curved glass panel. So the curved glass panel is going to get adjusted as per the site condition. So it's supposed to leave the dimension of 1.7 meter, and then finally the curved glass panel will get adjusted as per the site conditions. This is the section showing the entrance paneling. Now, mind well that there is not going to be any lintel, RCC lintel, wherever you propose the main entrance door of your premises, because it is difficult to construct the RCC lintel there, because you need the flexibility for the planning of wooden paneling and the gypsum paneling around that, and sometimes the span also does not allow you to construct the wooden to construct the RCC lintel. Because of that, many a times we need to construct a MS lintel for the main entrance door paneling. So now you can observe the door height is 2.4. Above that, we want the glass and the glass door to be flush with the bottom of the false ceiling and bottom of the paneling. We don't want any other element to be seen. We want it to be flush. So because of that, the detail is derived in such a way that the MS lintel is little above 50 mm to 75 mm above than the final finished line. Then this particular MS lintel is hung from the RCC slab above by giving 600 mm L angles, which are welded to the box section below, and they are getting fixed to the RCC slab with necessary base plate and necessary hardware. All these elements are going to be part of your tender as well. If you in the next webinar, I will be taking you through a journey of how we are supposed to prepare the tender document. In that, you will come to know like why all these specifications are necessary to mark in the BOQ and the tender drawings as well. Here you can see the nosing also has the light element. So you have written that in the text format also. The step nosing with SS brush steel, C channel with concealed LED strip light. Because again, as I've said you, this particular drawing is going to get utilized by several contractors. Like the electrical contractor is going to lay a conduit for these particular lights well in advance, so that because of that it is important for you to display the lights wherever the light elements are going to be there, part of your design. If suppose this particular slit is also lit, then you are supposed to write it that the particular light element is there in this. Now, as you have observed, there is the RCC lintel, RCC beam here. We are taking support from this RCC beam. We are taking wooden support from the RCC beam to form a architrave for a frame project signage. In the earlier slide, you must have observed the frame project signage architrave is 6 mm wide and 600 mm height, and complete throughout the length it is going. Now you are seeing the section of this particular boxing. Now this particular portion of the boxing is done in wooden framing, and rest of the area has been done in GI framing, that is galvanized iron framing, because it's a gypsum false ceiling. The rest of the area is not a wooden false ceiling, but it is a gypsum false ceiling. So why all these texts are important for a contractor to know, like how he's going to execute this particular false ceiling at the entrance, main entrance. Whenever you give wooden framing and GI framing differently, whenever you show GI framing and wooden framing separately, and you have different finish for two ceilings, you are supposed to give a groove in between that. Like for example, the wooden boxing, which is a ACP finish, you cannot suddenly stop the ACP finish here on this corner because the fascia is finished with ACP, but you are supposed to take that finish till the bottom of this boxing. You're supposed to give a groove here, because the paint finish of the gypsum boxing starts from this particular point. And why that groove is important? Because you're changing the material and there is no level difference. If it is possible to create a level difference, well and good, it gets executed very well with the level difference. But if it is not possible to give a level difference wherever you are changing two materials, then you are at least supposed to give a groove in between that also acts like a expansion joint between two materials, because the wooden framing and the wooden material are going to are going to give a little expansion to expansion and contraction, but the gypsum ceiling is going to be a stagnant element. So it is better to give a gypsum. So we give 6 mm groove in gypsum sheet itself. The gypsum sheet is having 12 mm thickness, and in that also we give 6 mm groove wherever it touches the other material other than the gypsum material. Now this is the last slide to explain you more in detail about the details of the lintel. Now you can see I have marked RCC beam. This might be an RCC, there might be an RCC beam there, or there might be RCC slab there. So you're supposed to write the MS plate fixed to beam above welded to C sections. Then there is a 75 by 75 mm 6 mm thick MSC section, which acts like a lintel. Is a box element that is a 75 by 125 mm lintel made out of 6 mm thick MS flats welded to C sections above. And this particular detail is very, very important for you to show, because this detail is only going to get conveyed to the contractor that your false ceiling is going to get merged with the finished top of the glass door and finished top of the glass fixed glass partition. And in the above, just below the RCC lintel, there is a 75 mm by 65 mm salwood framework. to fix the SS patch fitting of the fixed glass. To fix the pivot, you need to hold that pivot firmly, and it is not possible to get that pivot hold in the MS. So we are supposed to provide a wooden framework just above the door so that it gets well fixed, because your door is going to get open every after 2 minutes or maybe 5 minutes. So the stability of the door is very, very important. Because of that, this particular wooden salwood frame will act like a stability for the pivot to get fixed. Similarly, while fixing the fixed glass, you are supposed to leave a molding here which will act like a beading. Like suppose if the in the later stages, if the glass breaks and he needs to change the glass, then he will just break open that particular molding, and he will remove the glass and change the glass. The glass is going to get fixed with skirting box. This is a detail showing the skirting box, where the skirting box is made out of the plywood, but the final finish of the blocks is 2 mm thick SS brushed steel metal strip. Then you're writing the thickness of the glass as 12 mm toughened glass. Then you're writing as a finished floor level. So you know that the height of the box is going to be 150 and it is going to get executed after the FFL. This detail A is for the light element, which I have shown you in the last slides. There was a light element here in the wooden paneling. The background of the wooden paneling was finished with ACP sheet, and the 50 mm glossy strip for 50 mm glossy C-section was having a light, concealed light inside that. So that detail also we have shown. So that's all for today. I hope you are now aware like how it is important for you to show all the small details on the drawing for you to convey to the contractor that how the execution of your concept should happen.